Factoring. Lesson 4, Applications of Factoring. Essentially in this, I'm going to go through and provide an explanation of each one of the problems that you could find on mathbits.com, or at least you could find them on mathbits.com at the time that I created this lesson. Okay, so the first problem, it asks or explains that the area of a larger rectangle is 6a times the quantity 4a plus 3, and the area of a smaller rectangle is 5 times the quantity 4a plus 3. What is the difference of the areas in factored form? First, you have to remember that things that you're going to look at first are area is equal to length times width. So I find the area of the larger one, and then I take the area of the smaller one. Now notice you can't just cancel. This isn't something multiplying, you're not dividing, so you can't just cancel those out. So you get the area of the large rectangle and the area of the small rectangle. If anybody watching the video sees I made any typos, please let me know. Difference means that you're subtracting. So I'm going to take and have the area of the large minus the area of the smaller rectangle. When I do that, I have to then distribute this negative to the 20a into the 15. When I do that, I then combine my like terms to wind up with the minus 2a here in the middle and the minus 15. Here is my finished answer. I don't need to refactor. I'm not asking you to factor these. I'm asking you to use factors, understand what factors are used for. Next up, AJ texts you that he has found the correct factors to the homework problem dealing with the difference of two squares. Which of the following could be the factors? And that's asking you these four over here. I've obviously got the one circled. How do I know that x plus 2 times x minus 2 must be the answer? Remember that difference of squares is a pattern. When you factor a difference of squares, you can simply use a pattern. That pattern is that given a squared minus b squared, you wind up with a plus b times a minus b. That's the sum of the square roots times the difference of the square roots. So then all you do is you look at which factors fit the pattern. This one does not fit the pattern because this would be x plus 2 times x plus 2. This is x minus 2 times x minus 2. So these aren't two different factors. This is 2 times a binomial. This is the only one that has something plus and something minus, the same thing. Next up, we have given 6x cubed minus 10x squared minus 8x and 2x times the quantity 3x squared minus 5x minus 4. We let y1 equal the first term and y2 equal the second term. How will the graphs appear when graphed on the same coordinate plane? Basically, it's asking you to compare these two. Well, first off, I want to put them both in the same form. I could either put them both in the same factored form or in the same standard form. In this case, it looks to me that it would be easier to put it in the standard form because I simply distribute the 2x. When I do that, I see that I have identical equations, which means I will have identical graphs. Now, you could also have graphed each one and taken a look. You should notice that they're both going to be cubics. And after studying the transformations, will one be stretched more, compressed more? Will it be more to the left or to the right? Things like that. Reality, it's just asking you to multiply the factors together and see what are the standard forms. I'm not going to ask you to compare a quadratic and a cubic because those are completely different things. All right. Now, a ceremonial rug or carpet is rectangular in shape and covers 2x squared plus 11x plus 12 square feet. That would mean the area. That does not mean to square that trinomial. If the width of the carpet is x plus 4 feet, express the length in feet. Again, we're going to use our knowledge of the area of a rectangle. The area is equal to the length times the width. Using what is given, 2x squared plus 11x plus 12 must then be equal to the length times x plus 4. That means I'm going to take the trinomial and divide it by the binomial. But at this point in the Algebra 2 year, you haven't done polynomial division yet, so you can't just divide. But notice that length is a factor and x plus 4 is the other factor. I have one factor, I need the other one, so really all I need to do is factor this trinomial. Again, I would not give you a trinomial that's not factorable if I'm asking you to solve this. So I would take 2x squared plus 11x plus 12, and I would factor the trinomial. You can use the box, grouping, guess and check, okay, the star. Here I'm illustrating the star. They all start with doing A, which is 2, times C, which is 12, and you get 24. So I have 24, and then I look at the middle term, which is 11. I need factors of 24 that will add to 11. Well, that's 8 and 3. Now, because A is not 1, I'm going to put AX underneath each one of the factors that I found. And I put the things in green that I'm just simply pulling straight off of the equation. The blue are the things I had to think about, I had to come up with. Now, once I have 8 over 2x and 3 over 2x, I rewrite the fractions and I simplify them. 8 over 2x simplifies to 4 over x. 3 over 2x, that's as simple a fraction as I can get. Once the fractions are simplified, I then do bottoms up. That means I take the x and I pull it up in front of the 4, and that's how I get x plus 4. And I take the 2x and I pull it up in front of the 3, and that's how I get 2x plus 3. I know it's plus and not minus because this is a positive 3 in the numerator. All right, so now I know x plus 4 was given as the width. So I checked. That checks out. 2x plus 3 is the factor I did not have, and so that must represent my length. The next question, a binomial is squared and the result is x squared minus 16x plus 64. What is the binomial? Well, a binomial is a polynomial expression with two terms. We have to know our vocabulary. So first, when I'm asking what is a binomial, I need something that's two terms. Squared means it's multiplied by itself. So I have something plus something or something minus something, that quantity squared or multiplied by itself. Well, to figure this out, I'm going to factor the trinomial, which means factors of 64 that add up to negative 16. That would be negative 8 and negative 8. So I have x minus 8 times x minus 8, which results in x minus 8 quantity squared. 1, 2 terms squared. That is the binomial squared. So the binomial is x minus 8. Yes, I should really say, boop. There's my binomial, since that's what the question is asking. Now, this next one. A couple of things here. When you're asked this question, or a question like this, which of the following expressions cannot be used to express the area of the blue shaded regions of this rectangle? Remember, cannot, not can. So as soon as you find it's one of the expressions that you could use, you mark it off. Well, I go back to area, and we're using rectangles. So again, it's just length times width, very basic. This large area is going to be x times x plus y. That's the area of the entire region. Then to get the area of the blue or turquoise region, I have to subtract the area of the white stripe. Well, the white stripe is y wide by x plus y long. So I'm going to subtract y times x plus y. So once I set this first equation up, this number 1, I come down here and I look across my problems. And lo and behold, here's x times x plus y minus y times x plus y. This is my first one. And so I can say that one gets crossed off. Okay? Now, because that can be used. Remember, I want to identify things that cannot. So this can be used. So it's not going to be something I circle. To continue, I'm going to multiply the first expression. I'm going to distribute the x, and I'm going to distribute the y. Once I do that, I have x squared plus xy minus y squared. Take a quick look across the three remaining. None of those are listed, so I don't have to cross anything off. Then I'm going to simplify this second equation or expression, and the xy minus xy creates a zero pair, leaving me with x squared minus y squared. Again, I'm going to look through the three remaining ones, and here is x squared minus y squared. Therefore, this one can be marked through. And I left it without coloring it in at first so you could see the whole item that was being crossed off. Finally, I have to look at x squared minus y squared and realize that this represents a difference of squares, which can be factored. How does a difference of square factor? Sum of the roots times the difference of the roots. X plus y times x minus y. Right here, x minus y, x plus y. This is turned around, but remember, the commutative property of multiplication means it doesn't matter which factor comes first and which factor comes second. So this one as well can represent the area of the blue shaded region. X minus y times x minus y is the only expression here that cannot be used to express the area of the blue shaded region. Everybody with it? Good? Fantastic. Those are some examples. Almost every example or problem that you have will have to do something with area. You all know area of a rectangle, length times width. Area of a triangle, 1/2 base times height. Using that information, you should be able to solve any of the applications of factoring problems.